Hey there, in this video we're going to look at multiplying complex numbers. Now the techniques to multiply complex numbers are similar to the techniques we use to multiply polynomials because we're dealing with things that have numerical components, just numbers like coefficients, as well as mathematical symbols. But the one difference is that I is not a variable like x. I is a number that is defined to have a constant value so that I squared is equal to -1. So that's going to add one little different twist at the end of our problems. So to multiply 6 times 7i, we're going to multiply those coefficients together and we get 42i. To multiply -5 times 2i, we multiply -5 times 2, that's -10, and we still have I. Now, if we're multiplying together multiple powers of I, then we're going to combine exponents together just like we would if we're multiplying two variables. So I times I is equal to I squared, and we also have 3 times 4, which gives us 12. We can extend this method to multiply as many terms together as we want. So if we want to multiply all three of these terms together, -10 times 5 times 2, well, -10 times 5 is -50, times 2 is -100, and we have 3 powers of I that we're going to multiply together, so that gives us I to the power of 3. But now here's where these problems are different from just multiplying regular polynomials. We can simplify some of these powers of I to write them as numbers. I by itself cannot be simplified any further because it is the imaginary unit. It's the basis of all the imaginary numbers, just like the number 1 cannot be simplified. But I times I, or I squared, that is defined to equal -1. So anytime we have I squared left over in our final answer, we want to simplify that and turn it into -1. So 12I squared becomes 12 times -1, which gives us the answer -12. Now let's look at what happens if we take some even higher powers of I. So I to the power of 3 can be considered as a product of I squared times I. And I squared is defined to equal -1, and -1 times I can be written as -I. So I to the power of 3 actually simplifies to equal -I. So in this final example we've got here, this I to the power of 3 we can rewrite as -I, which gives us the answer -100 times -I. Now we're multiplying these coefficients together. -100 times -1 is equal to +100. So this is +100i. We can continue and multiply even higher powers of I. So let's look at I to the power of 4. Well, I to the power of 4 can be thought of as a product of I squared times I squared. And each I squared is defined to equal -1. So this is the same as -1 times -1, which is equal to +1. So I to the power of 4 is actually the same as the real number 1. And we're going to use that fact to multiply out these higher powers of I with exponents that are larger than 4. One way we can think of I to the power of 5 is that's just I to the power of 4 times another I, where I to the power of 4 is equal to 1. So this is 1 times I, which is just I. I to the power of 6 can be broken into I to the power of 4 times I squared, and I to the power of 4 is equal to 1. So this is 1 times I squared, which is just I squared. And you're probably noticing the pattern here. We break down higher powers of I into I to the power of 4 times whatever power of I is left over. So I to the power of 7 is I to the power of 4 times I to the power of 3. And we already know what I to the power of 3 is equal to. That's equal to negative I. And I to the power of 8 gets right back to where we started with I to the power of 4 times itself. And since both of those are equal to 1, I to the power of 8 is 1 times 1, which is just 1. So that's one of the notable properties of this imaginary unit I, is that as we raise it to higher and higher exponents, there's a repeating pattern every fourth exponent. And the pattern bounces between I to negative 1 to negative I to positive 1, and then repeats back to where we started with I. So when we're multiplying expressions that have coefficients as well as this imaginary unit, we'll multiply the coefficients, the numbers together, and at the end, possibly simplify the power of I. So let's finish with a few more examples. To multiply this first example here, 4 times 3 is 12, times 2 is 24, and we have I squared times I gives us I to the power of 4, and we can simplify I to the power of 4 to equal 1. So this is 24 times 1, which is 24. In the next example, we'll multiply those coefficients. 5 times 10 is 50, and I to the power of 3 times I to the power of 2 is I to the power of 5. So let's see what that simplifies to. Well, we can see I to the power of 5 is just the same as I to the power of 1 because the pattern repeats every fourth exponent. So this is really the same as 50I. And in this final example, we've got two coefficients to multiply. 8 times 3 gives us 24. I times I is I squared. And I squared simplifies to negative 1. That's the definition of I, is it's the number whose square is negative 1. And 24 times negative 1 is equal to, meant to do that in green. 24 times negative 1, well, that's equal to negative 24.